Good morning, good afternoon, good evening, everyone. My name is Erik. I'm the CEO of Demand Driven Technologies and delighted to be here to kick off our 2022 Global DD Tech User Conference. Thanks so much for joining. We've got quite a bit of great content coming over the next 3 days, so hoping you're going to be able to participate in most or all of the sessions. I think you're going to find it quite informative, useful information, and things that you can apply as you all pursue your own demand-driven journey. Couple housekeeping items here as we get started. Nicole's going to be posting the website link where you can access the full conference schedule. So hope you take advantage of as many sessions as you can participate in. As we go through these, you'll be in listen-only mode, but that doesn't mean we're not interested in your feedback and your questions. So please use the Q&A section on your Zoom control panel, and we'll use that to cover off questions. We've got about a 90-minute session this morning, a lot to cover in the DDOM. So I may actually take a couple breaks as we go through the presentation to take some questions along the way so we don't have all of them right at the very end. So as thoughts come to your mind, as things happen in the presentation, please feel free to ask questions and we'll get as many of those covered off at the end as we can. We are recording the conference. Each session in the conference, those recordings will be available later on, and you'll get more information about that as we go. We also, as our tradition has been since our first big user conference back in 2018, we like to hold the world's most riveting panel discussion to close out our sessions. And typically we bring thought leaders in to sit in and take your questions. The key to having a riveting panel discussion is all about the questions. So we very much want to get your thoughts and ideas. And so there is a Google form that we've set up where you can submit the questions that we'll then ask our esteemed guests, which will include Carol Patak and Chad Smith, to get their insights and perspectives. We've got a number of key executives or thought leaders who will be participating in that panel discussion. So very much hope you can be part of making it the world's most riveting panel discussion. You'll also find at the end of the Zoom session today that there will be a short survey. We'd appreciate your feedback. So if you get a minute to complete that before you close off, that will be greatly appreciated. We really value feedback from our clients and our audience. Helps us make the content better for all as we go forward. So enough with the housekeeping. Let's start into this concept of what the demand-driven operating model is. And before I do that, I just want to first give a big shout out and thanks to Carol and Chad for the great work that they've been doing in this arena. 21 years ago, I think it was a little later in the year, so it's probably in the summertime or something like that, I had been working with Dr. Goldratt, and he was starting to form what became known as the TOC-ICO, and we helped provide some meeting space for a conference that was held here in Atlanta. And I had worked with Chad, I had worked with Dr. Goldratt, I got to meet Carol at the conference, and it really was an interesting period for me because I was learning a lot about the application of theory of constraints and concepts like that, and we were applying those internally at IBM. And to see the work that Carol and Chad, both who have had very close relationships with Dr. Goldratt, taken those principles and those ideas of TOC and evolved them into what are now the really content and the ideas and the methodologies being promoted by the Demand Driven Institute. Chad had taught me my first Jonah class, took myself and my staff through a Jonah training. He had worked with Goldratt at the Goldratt Institute. Carol had worked with Ellie on the publication of the Necessary But Not Sufficient book. And so, they all brought these wonderful ideas together. And as you'll see when we go into the demand-driven operating model, I think some of the roots of TOC thinking become even more evident as we go forward. So I wanted to say thanks to Carol and Chad for their giving me the opportunity to use their presentation materials for today, but also for the great work that they've been doing, for blazing the trail around these demand-driven concepts, and for really creating an environment that is continuing to grow at a rapid rate all around the world. We're going to go into the demand-driven operating model today, and it's a big step forward from starting with demand-driven MRP, and we'll get into that in a little bit here. But I did want to thank Carol and Chad for their contributions that they're making and for, our collaboration over the last 21 years. It's really been a great, great journey. There were a few tenets or concepts or takeaways from my time with Dr. Goldratt that I found really compelling. I had read the book, The Goal, a number of times. I was the VP of Ops for the consulting division at IBM at the time. And we were trying to transform our organization, both from a skills standpoint, but also the market offers that we were taking out to our clients. And one of the key elements of it was the resource management. So we had consulting skills. This is the late 90s, early 2000 timeframe. And if you remember back then, for those of you who have a little bit of gray hair, it was a very transformative period in the IT landscape and the like. We had clients that were moving away from legacy systems and adopting ERP. The e-business explosion was really taking off at a big pace because the internet was becoming a viable platform for businesses at that point. And that was creating a lot of disruptive forces in the market. In our environment, in our consulting division, we had a big imbalance of skills, too much of the wrong, not enough of the right, meaning that we had a lot of legacy skills and other talents that were related to areas that were not as much in need any longer. And we were trying to transform, and yet in a consultancy like that, you're typically operating in a partner-centric kind of model where the partners each have areas of thought leadership that they're responsible for, or service lines or factors like that, industry areas. And they tend to always have a great forecast of the business that they're going to sell. And yet we were finding that some of them had declining consumption and others had so much growth opportunity that they weren't able to get to because we had not moved resources from one set of skills to another fast enough. And so we used a concept that we developed with Chad's help called replenishment for resource management. I mean, the whole idea was to use some of these TOC ideas to create essentially stock buffers of our consulting skills in areas that had declining rates of consumption based on actual hours billed. Would have to start letting go of people so we could put them through skill transfer programs and move them into more effective areas. And it was having an amazingly positive effect for us in a very, very difficult time. And all of that came through my collaboration with Chad, the time I was spending with Dr. Goldratt, who had been interested in working with IBM anyway. So it was kind of a very fortunate set of circumstances that I was able to get that opportunity to work with the guy. He was brilliant, unbelievably smart. But there were a couple takeaways that were really profound. And if you study TOC, you'll understand where these are coming from. First and foremost, it's about finding the point of leverage. Ellie was very well known for quoting Archimedes, give me a lever long enough and a place to stand and a fulcrum and I can move the world. And, theoretically that would be possible. And it's about it's about finding that point of leverage, because when we do that, we minimize the amount of extra things we're trying to do. And we gain better control of those things that are most critical to our success. We're going to get into those concepts here as we get into the demand-driven operating model. And then the other one, obviously, was, he said it in different ways, but the way I remember it was wait as long as possible before taking an action. Meaning that the more we take and put dependent actions in place on things that are well out into the future, the more likely we are to have variances and issues due to that, meaning pace to actual demand. And these are the core principles that Carol and Chad have really embodied in all of the demand-driven concepts. We call our company Demand-Driven Technologies because we believe in this principle as well. And they're obviously essential ingredients of what we're trying to do with the demand-driven operating model. So find the point of leverage. How do we gain control without trying to control everything, right? Because it makes our job easier. It gives us a better way of focusing and we get better results as a consequence of that. And then pace to actual activity in the market. Try as much as possible to get away from the damaging effects of the erroneous forecasts and use that as kind of the operating principles that we go. So as we go through the DDOM, this is, I think, the evolutionary next step for those of you who started with demand-driven MRP. You'll see a lot of familiar stuff in the presentation this morning. but maybe haven't gotten to the other side of that equation, which relates to demand-driven capacity scheduling, as it was known in the TOC days, drum buffer rope. A lot of those same principles are brought forward in DDOM with a little bit different packaging, and I think a more complete way of expressing how they coexist with other things like stock buffers. So let's get into it. And remember, please use the Q&A section to ask your questions. I'm going to keep an eye on that little counter, and we'll take some breaks along the way if there's points where we need to do that. So let's start with the demand-driven adaptive enterprise. This is really kind of the overall picture that we're trying to pursue. On the left side, in the demand-driven philosophy, we want to pace our operations, which means how we manage materials and inventory, along with how we use our production resources to the true consumption in the market. If we do that, we start with the most accurate signal we're going to have. And on the right side, we know that every company is evolving. Every business is going to be evolving as we go forward in time. New strategies are going to emerge. New competitors will emerge. There will be new opportunities that a company wants to pursue. So you always have to have a view of where you can go down the road in the future. On the far right of the chart, we're talking about the adaptive enterprise. How do we evolve as an enterprise to be more and more adaptive going forward? And in the middle is the link of what's called demand-driven S&OP. How do we take that vision of where we're trying to go with our company and use it as a way to influence and configure our demand-driven operating model? The idea of the demand-driven operating model isn't to be aligned to that long-range forecast or anything like that. It's to ensure that it's agile and resilient and able to flex to the real demand that comes in the market. If we configure, let me use my pointer here. Pointer options, here we go. If we configure our model correctly, this model configuration and variance analysis allows us to tune it to make it more agile and flexible to respond to the true demand coming in. The more agility we create in our business, the less dependent we are on precise forecasts and things that we know we're not going to be able to achieve anyway. So when we think of the DDOM, we want to think of it in this wider context, because it's important to understand that to be able to pace to actual demand, we have to know how to configure our model in a way that's going to be more effective, give us more agility, as well as more control of the way the operating model performs over time. These are really core principles. We're going to go back to those points of, finding those points of leverage and control, as well as, how can we pace to actual demand in the market in the best way possible, because we know that's a cleaner signal that we can be working from. All right, so let's get into it. Let's talk about the demand-driven operating model. And what we want to do is understand why and where are there opportunities to apply this. So I'm going to go ahead and build the whole chart here. Let's start with the concept of understanding the difference between what is called customer tolerance time and our cumulative lead time. These are the two dimensions down here in the lower right. Customer tolerance time is how long will the customer wait after they place an order to receive the material, where if you're behind that or longer than that time frame, they're going to go find other sources of supply. This is a critical dimension that you have to understand in your business. And obviously you have to build and design your operating model to do the best it can in supporting the customer tolerance times that you're going to be living with. The cumulative lead time then obviously is the length of the chain that you've got of dependencies in producing products for the market. And a lot of times when introducing DDMRP to clients, they'll say, well, I can't wait till the actual orders come in because I have to ship within 48 hours and I've got 30-day lead times. And that's where the concept of stock buffering comes in and how we can compress and decouple lead times to achieve that. So it's important to understand these dimensions, how they work together. Now, we understand, and I think everyone would agree, that the longer my lead time is, then obviously if I'm following a forecast-driven planning approach, the more error I'm going to be accumulating. Because the further out into the future we go, the less likely our forecast will be accurate. And there, I don't think could be any denying that this is an effect that we have to deal with. So what we want to try to do is compress our lead times as much as possible, because they start to reduce the amount of signal variation that we're bringing into our system. So this idea of decoupling that we'll get into here in a few minutes becomes an important dimension. At the same time, when we look at it from a production standpoint, the sooner we start and activate resources based on some forward-looking signal, the more likely it is that we are going to accumulate delays because of production issues. I mean, Murphy's Law, you name it, variability in the rates of production, machine breakdowns, supply constraints, you name it, we're going to accumulate more delay. And so these things are working against us. We have an error-prone signal when we're dependent on forecasts. We're also using longer lead times and longer frozen periods. That gives there more opportunity to accumulate delay and other issues. And obviously, when we have this kind of a scenario where customer tolerance time is far shorter than our cumulative lead time, these are the opportunities where we really are in good position to take advantage of the strengths of bringing in a demand-driven operating model. Okay, so why does this matter? Well, we've all heard the term VUCA, volatile, uncertain, complex, and ambiguous. It kind of describes, especially the last 28 months that we've all lived through with the pandemic, but it really even applies outside of that. The notion is that there is more and more global competition. There's more volatility in the markets. Clients, with the Amazon effect, want things now. They want to choose from a wider and wider range of suppliers, you name it. And it's made it a very challenging and complex world. That doesn't mean we need more complexity to solve the problems. In fact, I think the strength of these concepts is that we start to introduce ways of dealing with the VUCA conditions in actually a more simple and straightforward way. And a way that, or a method that allows us to also focus our energies where they're going to do us the most good. Very much along the philosophies of find the point of leverage. Let's not try to boil the ocean here. Let's try to insert the right tactics that are going to give us benefits, given the types of variation and other conditions that we're trying to deal with. Okay, there's 4 key principles here: position, protect, pull, and adapt, that are kind of foundational to this whole idea of the demand-driven methods. Position and protect. Where are we going to generate buffers? Where are we going to put stock, time, capacity buffers? How do we position points of leverage in our model that are going to give us more control of how we operate so that it really affects and gives us that kind of agility that we're looking for? Pull is the whole idea. Let's pull to real consumption in the market. It's going to have an impact on how we develop our operating model, but that principle, I think, is proven over and over again to be more effective for clients than the one that is push-oriented or forecast-driven kind of an approach. And then adaptation, or how we use a closed feedback loop, and that's that cycle that I was trying to illustrate between DDOM and DDS&OP on that first chart, of bringing a feedback loop, using it to configure and adjust our model, to continually build more adaptation and agility into how we operate on a day-to-day basis, because that gives us the greatest flexibility and ability to improve our on-time order fill rates and to reduce working capital, compress lead times, and other factors like that. And these are kind of continuous loops, and that's really the role that DDS&OP plays in helping continually adapt the demand-driven operating model to be appropriate for the conditions you find in the market. So there's 4 critical elements that we're going to talk about, and I'm going to go from right to left here. Pace to actual demand. Again, this was the point that Ellie was making so many years ago. Wait as long as possible, but not too long before taking an action, because it makes the accuracy of what you're doing so much better. So we want to use that as kind of the foundational principle. And instead of depending on what I'll use as kind of conventional MRP logic, which was a very logical concept, start with the demand you need to satisfy, and then we'll backwards schedule all the things you need to buy, assemble, manufacture, package, and distribute to meet that demand. All makes perfect sense, and it's all linked together, and it's a beautiful concept in that sense, except it is dependent on one critical assumption, and that is that the forecast is going to be accurate, that demand is known, as Chad likes to say. And obviously, we've seen time and again how perilous that journey can be because of product proliferation, competitive forces, unknown events that are going to come along the path, reliance on forecasts, especially at the item level, becomes very, very challenging. And obviously, the underlying assumption there is that we're going to have a good forecast. And when you look at so many of the tactics of the last 30, 40 years, it's all been about get your forecast better, get your MRP standards better, boom, boom, boom. All those things are going to get us to a better place. And by just unblocking that one assumption that the only way we can pace the actual demand is to have a good forecast, if we understand then that the use of buffers, decoupling points, and control points starts to give us the ability to pace to actual demand with the appropriate stock in the right places to do that, now we've unlocked a whole new wave of opportunities, and that's really what we're trying to go after here with the DDOM. We're going to talk about decoupling points. We're going to talk about control points and operational buffers. You'll start to see how those come together here in the coming few minutes. But again, the idea here is let's wait as long as possible before taking actions. We're going to build stock buffers. We're going to build control points, and we're going to do decoupling where it makes sense. And those are going to give us a much, much better operating model to work with going forward. All right, so let's get into decoupling points. And those of you who've been in the DDMRP training, you're going to understand this quite well. So apologize if I'm going over some old ground here, but I think they're really important foundational. Remember, we're trying to recognize that customer tolerance time, how long the customer will wait, is much shorter than our cumulative lead time. And so we need to find ways to break that paradigm. And there's often very, very wide disparities, especially if companies have gone to offshore sourcing of certain materials. That cumulative lead time horizon may be as much as 150, 180 days. In some of the supply constrained environments, we're seeing numbers far greater than that. And yet the customer is still demanding kind of immediate service. So we've got a real difficult dilemma here to deal with. If we look at it from a product structure standpoint, we can start to get an understanding. If you look here, this is a simple little bill of material. FPG is a final product, and it shows the components that go into it. They've got a sub-assembly or an intermediate assembly here. Item 101, these are the lead times. So we've got 30 plus 3 plus 7. So we've got a 40-day cumulative lead time here. And this is maybe, far shorter than the 2 or 3 day customer tolerance time that we're trying to deal with. And obviously, the larger that gap is, the more prone we are to forecast error. That's again why we want to use the demand-driven concepts, because they're going to give us cleaner starting signal to start with. And we know that inherent variability is going to impact as we produce this item FPG, that the longer that lead time is, the more our planning horizon stretches out, more frozen period stretches out, the more likely we're going to see some delays accumulate. It's often said in the TOC world that in terms of schedule, delays accumulate, but gains never will, right? So we don't really get the benefit of gains very frequently, but the delays will certainly hurt us, and we need to protect ourselves from having that happen and influencing our on-time order fill rates. Now, obviously, there's also this issue of dependency in conventional planning, where everything is dependent, meaning that signal through our bill of material is all linked together. There is no decoupling and breakpoints in the middle there. And as a result of that, we find ourselves in this bullwhip effect, system nervousness, and what we see as bimodal distribution of inventory, where we've got too many of the wrong items and not enough of the right. So we're going to see demand signal distortion and nervousness increase as we go from the end item down to the supplier side. We want to try to avoid that because that makes life very difficult for our suppliers. And then obviously too, where suppliers have issue, that can accumulate and cascade into other problems. We've seen this with many clients who, like in the automotive industry, have been impacted by chip shortages or other material constraints and things like that, that it's just exacerbated itself. They're seeing variance in the signal coming from the original equipment manufacturers, the automakers themselves, and at the same time, they're contributing to nervousness and variability because of their own supply issues that they're fighting to deal with. We're having a thunderstorm here in Atlanta, so you may hear a little rain or thunder in the background. My apologies for that. At the company level now, what we find is that we tend to oscillate back and forth. We've got too little, we've got too much, We never seem to be able to find that balance point. So we need to figure out, how do we create the ability to narrow this range? How can we bring this distribution more in line? Decoupling points are going to play a role in that, because they're going to be utilized to help address some of the variation that we're seeing, both from the demand side as well as the supply side, and then obviously across the layers in our supply chain. It may not be all under our control, but we're certainly going to be dealing with it as we go through time. Decoupling, this is in the APICS dictionary. It's been around there for years, probably decades. The whole idea is to create independence between supply and use of material. Commonly denotes providing inventory between operations so that fluctuations in the production rate of the supplying operation do not constrain productions of the usage. So in other words, we've got Kanban bins in front of a certain assembly operation to help ensure that those nuts and bolts, as an example, are always available and don't slow down the ability to produce that end item. And these also then can create a planning point where they're going to allow us to decouple. Because now, if we know that inbound material is always available, and we'll talk about this when we get into stock buffering, then that lead time is no longer in effect in our planning horizon, and we've broken the chain of variation from cascading through the layers of our activities and our supply chain. So this concept of decoupling is all founded on the principle that a DDMRP buffer is going to always have constant availability. By doing that, I don't have to wait for it. It's going to decouple my lead time and compress my lead time, but it's also going to dampen variation for me. Because when I don't have that decoupling or that independence between these two steps, now what I'm subject to is the amplification of that bullwhip signal, which obviously we want to leverage and get away from, because it will give us more control of our other elements in the system. Firewalls are ways to create barriers, bulkheads. There's lots of examples in life around decoupling points, but it's really important that you get your head around this principle, because it's so foundational. It's a core part of that whole paradigm, where with appropriately deployed DDMRP buffers, a client can actually shorten their response time to the market while at the same time carrying less inventory, which up till now has just been like a paradigm that most people couldn't envision. In fact, most companies, in the quest to improve service line or service levels, have simply poured more and more inventory at the problem. And that's not the right way to solve it, because you're still going to end up with that bimodal distribution if you're not pacing the actual demand. Okay, so how are we going to size these? How do we come up with ways to do this? Because in the DDMRP methodology, we're going to refer to this as a stock buffer, but knowing that we want to decouple and how we decouple are another thing, and we need to get into how we create those buffers, right? How do we do this in a way so that we can really pass the test? The idea of a decoupling point is it has to service both sides of the equation, meaning it has to benefit the supply side, and it also has to benefit the consuming side. So we're going to look through our product structures. We're going to look through layers in our supply chain. What are those strategic points where we can make the proper decisions around how we're going to decouple? It's oftentimes, in principle, from an application standpoint, what we find is that the first place to look is all your purchased items. Why? Because your purchased items tend to have the longer lead times. If you go back to that cumulative lead time horizon, most of it typically is going to be in the purchase of materials. In some heavy engineer to order environments with heavy project management and unique bespoke to a given client end item fittings and fixtures that they've got to build, maybe it's in the manufacturing process, but in the by and large, most all companies, the biggest opportunity for gain here is going to be with our supplied in items. But there will be intermediates. There will certainly be end items where it will represent great decoupling points. And so obviously we want to go in and treat this with a fair bit of care and find the best way forward based on applying the DDMRP concepts. So where do we decouple? Are there some elements within the model that we're going to get more leverage? Will they promote better flow? Maybe they're both difficult areas because of production variability, as well as, impact on end item. So we want to have protection there. In other words, intermediate buffers would be very helpful there. How do we size those protective points? We need to know that we got the level of variation that those points are going to incur covered. We need to know that the lead times of resupply have been adequately provisioned for. We obviously need to know that what our resupply orders are going to look like from the standpoint of, are there minimum order sizes or batch sizes that we need to be thinking about when we deploy the stock buffers to create this decoupling from a stock standpoint. So there's a number of factors that go into this. I think every company kind of looks at this and they've got a lot of local knowledge. But from a textbook standpoint, you've got things like customer tolerance time. What is the time the client is going to wait for the order? Market potential lead time. This is looking at it a different way. It's not just, what the customer tolerance time is, but if we as a business could improve our lead times to some factor better than where we are now, will that grow our business? Will we get more business because we can be more responsive to those in the market that we're trying to serve? And I think this is really an important factor to be considering because it's a very competitive world out there. And the more able you are to give clients exactly what they're asking for in the time frame that they're asking for it, the better off you're going to be. What is our sales order visibility? Obviously in retail, it's what customer comes in and takes things off the rack. Typically in business to business kind of environments, there's a little bit more visibility. We've got a number of companies in our portfolio that are in the food and beverage space, including Coca-Cola, Beverages of Africa. They've got a fairly good order book, probably out a couple, 3 days, but not much beyond that because of the nature of the products that they produce. Other companies will have a little bit longer lead time. So you need to look at that as a consideration when you look at your decoupling points and where can we get benefits on that. How much external variability? This is really the market variability. Firstly, I think is more the way most people think about it, but it's also supply variability. Everyone I think out there has been impacted by supply challenges, and we've even got a module tomorrow where Bernard and I are going to be talking about some tactics around how to address the supply, how to use DD tactics when you're dealing with heavily constrained supply environments. So supplier disruptions, supplier changes in lead times, the more you've got challenges on that front, the more you want to be obviously considering or protecting yourself from that by putting decoupling points or stock buffers in to help address that. Where do we get leverage on inventory and flexibility? That's kind of typically going to be within your bill of material. Any shared intermediates typically represent good opportunities for buffering because they help to compress the lead time of the end items that they go into. So that's kind of big, within the bill of material. And then obviously too, where we have critical operations that may have exposures to their own variation, perhaps an unreliable process, perhaps a process that is heavily influenced by weather conditions, like a heating cell or something like that, or a paint booth where humidity and other areas can impact its production rate or things like that. Then whenever we can use stock buffers around that, we tend to also help protect ourselves from some of the challenges that we may experience in our operation side of the house. So that's a quick little look at control points. I see there's a couple questions, so I'm just going to take a minute here to see what questions have come up. Will the presentation be distributed? Yes, sir, it will. What's the best way to identify decoupling points? Great question. One of the things that we want to do is we want to look for items that have frequently, so let's think about it from the purchase side in. We obviously want to look for items that have recurring usage and have a reasonable level of manageable variability. In other words, if we have items that have extremely high coefficients of variation, meaning that the standard deviation versus the average is 5, 6, 7 times the average, those are going to be challenging to buffer effectively because, yes, you can buffer them, but it's going to take quite a bit of working capital to do that. And oftentimes you'll find that that's not a good trade-off, and those would tend to be buy-to-order items. So typically you're going to look for that sweet spot, which are going to be items that have lower levels of coefficient of variation, recurring levels of pull, and which represent areas where we can get better benefit by decoupling any supplier variation from the system. If we do our purchased items effectively, probably 85 to 90% of what we're going to gain in terms of end item decoupling and lead time compression is going to come through our purchased items. So it's always best to start on that side of the equation. Within that, when you look at intermediates, theoretically, they may look like great opportunities, but too often what you'll find is that the intermediates aren't really viable because maybe the plant isn't set up well in that environment. We're taking and creating a stock buffer of some intermediate assembly just doesn't make sense. We don't have space for it. The way the production flows are laid out on the shop floor isn't conducive to that, or things of that nature. So when we get into intermediates, obviously we want to be careful and not miss those opportunities because they can really have leverage, especially if they have shared parent item. They're shared by many parent items. But on the intermediate side, there's a lot of other external factors. They may qualify because they've got the right amount of recurring pull, manageable levels of variation, and things like that. But if they're not viable for other reasons, shop floor layout, double handling of material, you name it, it may or may not really apply in practice. And then on the end item level, then it's really, again, back to the question of, do we have adequately stable recurring demand for these items? Do we want to commit working capital because that will compress our lead times? Now, remember, if we've got finished good buffers, that means you could basically ship the next day. And that is an incredibly attractive response time to have to markets. So obviously you want to pursue that to the greatest extent possible. And maybe what you're going to do if you're in a configuration to order kind of business is you're going to build a lot of product that just needs to be kitted together, or some very rapid final assembly to make it fit the client's request. So on the end items, you're going to look for recurring pull. You're going to look for manageable variation levels. And then you're going to also be clearly looking at where can we gain some market advantage by being able to be much more responsive than our competitors. That same kind of logic would also apply out into the distribution network side. So Ramesh, hopefully that answers your question. We'll continue on. And if you have other questions, let's keep bringing them. So now let's get into the idea of control points. We've talked about decoupling. Now we're going to talk about what are control points all about. Oops, I'm going to click here. All right, again from the APIC definition. Strategic locations in the logical product structure for a product or family that simplify the planning, scheduling, and control function. Control points include gating operations, convergent points, divergent points, constraints, and shipping points. Detailed scheduling instructions are planned, implemented, and monitored at these locations. So what that means is these are points where we can exert some control on the environment. Now, I think Chad and Carol made a little bit of an edit to the APICS definition here because they think of it really more in the context of the routing. What are the activities to produce that end item? How can we gain control of the production environment in a logical way so that we can get more predictability in terms of promised date performance, the management of schedules at each of the resources along the way, and how do we then stabilize our production operations so we're not in constant firefighting and expediting mode. So it's really more related, we think, to routing and activities than it is so much to the product structure side of things. So like you have decoupling points in your materials, in your bill of material and the like, in your routings, you want to look at where can we insert control points. These are going to give us control of the activity on the shop floor. They also help impose some control so that the level of variation that goes through the system becomes more effectively managed. So remember, it was talking about points of divergence or convergence. You know, we know about V and A-shaped plants, T-shaped plants, and things like that. And so when we look at our routings, and this is part of the activities we'll go through a little bit when we talk about scheduling and execution tomorrow, what we're looking for, where are those opportunities where within the environment we can gain more control. We don't want to put too much material out on the shop floor too soon. So the entry point of the production flow is a critical part of it. At the other end, the exit point where we're shipping out, we want to make sure that we've got control of that as well so that we can improve our on-time order fill rates and the like. And then in between there, where are those points that we're going to get better leverage on the model? Entry and exit points, just what we talked about, right? We get better operational control when we can handle the entry into the production environment as well as the exit. And this is really, starting to get better management of variation and the issue of delays and gains. We keep those within our operating environment. That makes us much more dependable to our clients and manages any supplier variation that we're having to deal with. Now we get into the good stuff. I love the concepts of drum buffer rope. They're called pacing resources in the demand-driven capacity scheduling or DDOM kind of context. These are pacing resources are going to determine the output of the entire environment. And if you've read the book, The Goal, you know about Herbie, you know about the, I think it was an NCX10 or something like that machine and at the plant that they were fighting with. It's the idea that we have to recognize that there are certain activities within our process that are going to determine the output of the entire system. And so, we've got the tortoise and the hare here. The rabbits can run real fast, the tortoise not so much. And yet if there is a dependency chain between all these steps in our routing, then at the end of the day, the tortoise is going to determine the output of the entire system. So downstream here, we've got way more sprint capacity than we have at the tortoise. So unless there's other feeding operations coming into these resources, they're going to be underutilized. And that makes some people who are heavily tied to operational efficiency metrics a bit nervous. But as you'll see in a few minutes, those represent capacity buffers for us because they have capacity greater than what the drum is going to be running at. And that gives us flexibility for catch up or dealing with the variations that still may exist between these process steps, either upstream of the drum resource or downstream of the drum resource that can affect our ability to fill orders on time. Okay, what are common points? Common points are resource areas where activity or manufacturing routines either come together or deviate or diverge. These are very helpful in gaining control on our environment. So, you can have a given point that obviously affects multiple paths or value streams, if you will, if they flow through a common area in the plant. Typically, test, paint booths, areas like that where every product goes through them at some level, oftentimes are going to be, kind of great opportunities to create pace setters or drum resources because everything is going through those activities. And the rate of output of those common point activities are really going to determine our total output in a much more effective manner. We have to look out for unstable resources. These are items that have high levels of variation. The more instability we have, the more important it is that we manage them. So, this may seem a little counterintuitive to some, but actually the fact that that process is less predictable makes it an even better point to be pacing your activities from because it's going to give you more control. And so again, like I mentioned, sometimes you've got process steps that are, influenced by weather or atmospheric conditions or whatever. Those often represent great opportunities. Companies that are in electronics often have yield situations that they're trying to deal with. And so those test cells that determine what yield you're getting out of printed circuit board manufacturing or things like that can be heavily influential on how you gain control of your manufacturing environment. Obviously, if you don't do that, what you're doing is you're creating the opportunity to amplify execution variation as it goes further downstream. So let's try to get control of those if they exist and really make sure that we're managing them in an effective way. So let's see if we have any new questions that come up around control points. Is a decoupling point independent of a control point? Yes, a decoupling point is going to be a stock buffer. You'll see in a couple charts, Ramesh, we're going to have a view of like suppliers where you've got stock buffered of supplied items and they're at the same place in the routing where we have a control point, which is the entry point into production. And those are going to influence our release schedules of materials onto the floor and things like that. So decoupling points and control points can also be at the same place in the product flow, if you will, or the production flow, but they're really two different concepts here in the way we think of the DDOM operating environment. So now let's talk about buffering. Why do we have buffers? The reason we have buffers is we know that there is variation. Just like you have shock absorbers on your car to dampen the variation and issues on the road that you drive down, there are opportunities for us to bring buffering into our environment and create more stability and more operational balance as we go forward. So, and again, I got to click twice here. So let's think about the buffers that we have within the demand-driven operating model. If you've done the DDMRP path, you understand the idea of a DDMRP buffer, a stock buffer, placed at the product structure level, either at the bottom of the bill of material in the purchase items coming in, some select intermediates, or at end items. Those are going to create a way for us to decouple lead times and also dampen variation. So stock buffers are pretty well understood by the demand-driven MRP community. Those that getting into DDOM, which is really the other side of that, is production scheduling and execution. That's where we start to think about these other two types of buffers. Time buffers. These are inserted time within a routing, meaning that we want all of the prerequisite steps before we reach the constraint to be buffered by time. There will be a time buffer in front of the constraint so that any upstream variation that accumulates over time before we get to that step has been dampened from impacting the constraint schedule. Time lost to the tortoise is time lost to the entire system. So we don't want to let that happen. And so we want to protect ourselves from the impact of upstream variation. Ellie's way of verbalizing this was identify the constraint, subordinate everything to the constraint, meaning make sure that everything done possible to protect that constraint schedule. Then obviously elevate the performance of the constraint, because now once you understand where your constraints are, steps that you can do to improve their run rates, their efficiency, their reliability will improve your entire output of your system. And obviously you never want to starve a constraint resource for material. And that's why we put time buffers in front of them. If I have a large complex routing set of steps in front of my drum resource, that time buffer may need to be larger. If I have a very simple one, it may be quite small. So again, there's going to be factors that will influence how much time buffering you put in. We'll talk about those tomorrow when we go through the scheduling and execution functionality in our Intuiflow product. Then there's a capacity buffer. And just like I mentioned with the hares, the rabbits who can run so much faster than the tortoise, they have sprint capacity. And they allow us to then absorb variation that may be happening upstream in those steps or downstream, because they give us enough flexibility within the resources that are in that routing to make sure that if we need to catch up for some reason, that we've got the flexibility to do that. Very important. Oops. Whoa. So let's go through now what these are doing for us. Stock buffers absorb variation in rates of demand, or they can absorb variation of rates of inbound supply. The time buffers are going to absorb for delays that accumulate upstream of that time buffer, and they help minimize the amount of variation that the constraint resource is going to be impacted by. And then capacity protects us from how much load is actually required. If we've got enough sprint capacity, we know that we've got enough headroom in those preceding steps, then we know we're going to be able to keep the drum resource saturated with adequate work to maintain its efficiencies and effectiveness. All right. I don't see any further questions. So let's dive in a little bit on DDMRP stock buffers. So now we're talking about how we're going to apply technique into this demand-driven operating model. Anybody who's been through the DD education, demand-driven MRP education, understands the purpose of these buffer zones. The green zone is going to be our average order size or frequency. Oftentimes it's going to be determined by minimum order quantities from our suppliers. In production items, it's going to be reflecting of typical batch sizes. We want to give careful consideration to what those values are, because they're going to have a big influence on order frequency as well as our on-hand stocking levels. If we have very, very large green zones with very, very long lead times, we are putting ourselves in a less favorable position. So the more familiar you become with DDMRP buffers, the more effective you're going to be in managing those as we go through. The yellow zone is the heart of demand coverage. What it really means is it's the amount of supply to cover that time from when we issue the order to when the material arrives. We order at top of yellow, we should receive at bottom of yellow if the lead time is achieved and the rate of usage is consistent with what the buffer has been configured around. And then obviously the red zone is going to be protecting the safety in the buffer. This is the whole principle of constant availability. If we have constant availability, we can decouple. That upstream lead time is no longer relevant. So I can compress my end item lead time dramatically by just carrying the right stock of those purchased items coming in. I've made myself more flexible to the market, and I've also typically reduced working capital substantially. The key in demand-driven MRP, more than anything, the big distinction is we go away from forecast mania, where we're trying to get the forecast more and more accurate, to understanding the impacts of variation. It's variation that matters more. And this is why we're really heavily invested in AI and machine learning, because we think that and believe and are convinced that the more intelligent we make the management of variation, the more effective DDMRP buffers can be placed, the more reliable and easy to configure they will be for our users. And this is going to give us that's kind of the heart of the matter here from a demand-driven MRP standpoint. So we'll talk a lot about that. There's some elements that are in the textbook around how safety zones are configured and the like. It's basically going to be based on things like your decoupled lead time of the item, its rate of usage. In most parts, it's going to be a trailing average daily usage, a historical rate of usage. In some cases, you're going to use a forecasted rate of usage if you have heavy seasonality or other kind of promotional events and things like that to deal with. What your minimum order quantity is going to influence your green zone, and obviously your location, because your locations, where they fit within the supply chain, what risk factors you're trying to mitigate at those levels are going to influence the way you configure your buffers. We then apply those part traits to buffer profiles. We've got this idea that we are grouping things together because they've got common traits and attributes. And this simplifies the administration of our DDMRP environment. And when we combine those, we come up with the buffer zone levels, which are dynamic, recalculated on a flexible basis, and giving us the right kind of performance over time. I see we got a couple more questions. I'm going to hold off because I think I'm running a little bit late here. Let me check my clock here. Sorry, I've just lost track of time here. I want to make sure I'm not getting us too late. Okay, we got about half an hour still. Good. So let's get into time buffers. If you got more questions on stock buffers, there's a lot of education and training out there around DDMRP. That's really where the principles, you can really get a deep dive on those. But a lot can be found online through us, you name it. We can get you much more information around that. So let's talk about time buffers now. Time buffers, the basics here. They respond or correspond to the scheduled activity or point in the process. Let's say our drum resource is right here in the middle, and we've got 3 or 4 upstream steps that we're dealing with. What we're trying to do, again, is to protect that pace setter resource from not running dry. So we want to have some protective time buffer to absorb any variation that may occur in those upstream activities. And if some of these have a lot of variation, let's say this forming process may have, the tooling isn't quite as reliable, or maybe we're prone to manpower shortages or whatever, there's other factors, then obviously if we have those kind of concerns, remember, we're trying to make sure we're going to ship on time, and we know that this is the critical resource that's going to determine the output of the entire system. What we're wanting to do then is put time buffers in place to protect that drum resources schedule. Again, these will be sized differently based on the upstream activities and complexities. We'll talk about this in terms of a concept we call part families in our scheduling platform in Intuiflow that you'll get better visibility to. At the other end, we want to have a time buffer so that we're shipping on time. By this point, we should ensure, like labeling, I would put packaging in here personally because there's always some packaging step at the end of the line. We want that to be completed before it's supposed to be loaded on the truck. Maybe we want it done 8 hours ahead of time so that we know the product is completed. If there was any variation, that the load on that truck is not going to be impacted by the fact that we don't have the job completed. So that's the idea of inserting time buffers in our routings. They're going to be inserted in front of certain constraint resources or shipping buffers, as you may see going forward. How do we really manage these? So we're going to look at these from the context of we've got this queue in front of the drum resource. As these work orders arrive, and you'll see this in the buffer board tomorrow when we go through scheduling, you would see that the material has arrived at the appropriate time. We want it to come in the green zone, maybe the beginning of yellow, that's okay. If we start to see that the work orders are arriving just before they're supposed to go onto the drum, we want to know why that's happening. Because we have to have a process of ongoing improvement. When we're dealing in production, we're dealing with a number of other factors here that we don't really think about as much on the DDMRP side. And so we want to make sure that we're going to protect that resource. So we want a signaling technique that allows us to know when did those work orders arrive at the drum, were they received in the appropriate time window and brought into, the kind of the receipt buffer in front of the drum resource. Again, this gives us a good way to have a lens about process of ongoing improvement for those upstream steps in front of that constraint resource. That's a very simplistic way of looking at the time buffers, but I think it should give you a good sense of how they operate in practice. Again, it's inserting some time that'll allow us to ensure that we make our on-time order fill rates. Capacity buffers then are like the ability of the hares in that tortoise and hare example to catch up if we do have upstream variation that is risking our ability to meet our due date schedule here. So we have to insulate our control points. And this was the example, Ramesh, that I've talked about, where we've got a decoupling point in the stock buffer as well as a control point at the same place in the production flow. This is a control point because it's an entry point into the production process. This is a control point because it's an exit point in the process. This is a control point here as well. It's an entry. And then our drum resource is also a control point because it's a point of convergence in our path in the route. And we're trying to ensure that we're protecting against variation. So here we've inserted a time buffer in front of the drum resource that's going to help dampen any variation from the upstream side. It's also going to ensure that we're starting this final leg of our routing on time. And we're still going to have a time buffer if it's a make to order item in front of the customer ship date, or we're going to have a stock buffer if it's a make to stock item that will ensure that we've got availability to meet customer demand. So in these intermediate places, we want to have sprint capacity, meaning we don't want to have these level loaded to the same rate of the drum, because now if there's any impacts and variation upstream of getting to the drum, we are going to end up limiting the output of the drum itself. So contrary to this concept of having a balanced plan where all of them run at the same run rate or effectively the same run rate, we don't really want that. What we want is to gain control here, and we want to dampen variation. If these were all in a balanced manner and any one of them messes up, now we're screwed. But we're going to be short of utilizing the drum at its full capacity, and we don't want that to happen. So what we're looking for is sprint capacity to exist in these upstream and intermediate steps between our routing to ensure that we don't influence the activities on the drum, and that we don't influence the rate of shipments to our customers on time. So think about this. We've got different different resources in our routing, and all of them may see load and capacity in a different way. Those that have capacity beyond load have capacity buffers. We've got extra capability in our production resources. This could be machines, it could be human resources, whatnot. It could be an outsourced resource process step that we go through for plating operation or something like that. If we know that there's adequate capacity there, then they're not going to influence our execution to our promise dates. The ones that do show up like this are going to get investigated because this is likely going to be a constraint resource that's going to be finitely scheduled and level loaded, whereas these others will be infinitely scheduled. So all of that extra time is our capacity buffer. In other words, the difference between our capacity and our load is that excess capacity, and this is a way that we protect our system by having enough sprint capacity to be able to find our way through. It can be used in a number of different ways. Sprint capacity, we've got a drop-in order, or we've got to make up because a machine broke down and we lost an hour and a half of, while it was being repaired. So now we need to catch up. We need those upstream steps or downstream steps of that resource to help catch up for the lack of production that we had there. That's a real valuable capability to have. And remember, back when I first started this whole session, we talked about building agility into our model. The more sprint capacity we have, the more flexibility we're going to have. There's times when that sprint capacity can actually be sold off into the market, meaning it's not going to utilize the constraints. We can use those production resources for other outside customers or other divisions within our company or other purposes. So we can think about those in terms of what Chad and Carol call tactical exploitation. Are there ways that we can take advantage of that extra time that we've got there without endangering our own schedules, but use it to gain more, contribution margin and throughput or revenue for our company? And, or, if it's like a labor-oriented situation, maybe we can move some of our staff around on the floor in a more flexible way to give us more ability to address issues that come up, through variation within the production schedule that we've already issued out onto the floor. So you can think about this from the capacity of any resource can be divided into 3 zones. The green zone indicates the resource has flexibility to promote and protect flow, right? So that as long as we're operating down in this window, we're in great shape. Yellow zone, we're starting to kind of get right on the edge. And obviously, if we're up here in the red, now we're going to be a little too tightly bound. And especially if these are in upstream resources before the drum, we're going to be risking the performance of the drum, which is the last thing we want to do. And then obviously you'll see sometimes that those will go over capacity. And this may be because there's been a change in our product mix or the rate of demand. Maybe all of a sudden we're starting to see in our operating model that a resource is starting to emerge as either a constraint, and it's going to dictate the process outflow, or it's an opportunity for us to invest perhaps in another machine or additional human resources or whatever to bring it more in line so that it still retains the qualities of a capacity buffer within the environment. And these would be different resources within an environment. You can map them out in that fashion. You'll see in our system load graph in the scheduling platform tomorrow how we can visualize those and get a look at the items that are non-constrained resources and how their loading is looking. So one thing you got to keep in mind. In a flow-centric model, we look at them this way, meaning that we want to build extra capacity. We want to not be encumbered. We want to use that constraint as our scheduling environment to manage this in the pace through the entire environment. On the other hand, especially the finance guys are going to tell you, well, we want you to hit certain operational efficiency metrics. And there's this tendency, and it's so well illustrated in the book, The Goal, to push activities that are not needed. They're ahead of time. They're not waiting to the last minute. And that's because we want to activate the resources. And we have this, poorly informed judgment that the more active everything is, the more profitable we will be. And as Goldratt used to say, no one has sold until the customer has bought. So if we're getting credit at a manufacturing location for just producing output, even though that output is sitting in the inventory in the warehouse and not being sold to the market yet, we really haven't solved anything as a problem. And if we've done that because we're driving OE metrics and we're keeping everything busy and we're building ahead stock that isn't yet being sold, we're misusing capacity when other drop-in orders or other things that are happening in the market now have to wait, delaying our response time to the market in a fashion that's not favorable for what clients are trying to do. So we really have to pay attention to this because these cost center OE metrics are in every plant. I've never seen a plant that doesn't have these, and they are a very difficult issue to manage. Now, what I will say is that for the clients who've started to understand this differentiation, they realize that the flow-centric approach is far more effective. And they also see, quite honestly, that their OE metrics don't suffer when they migrate to this fashion. Because what is not really well captured is when you're driving cost-centric, how many times you've lost revenue because the customer couldn't wait for you because you've already launched a month's worth of work with big batches, and you're not going to mess up with the schedule because you've got a schedule adherence metric that you're also chasing to. And now we've just twisted ourselves into a pretzel over inappropriate metrics that are not going to really help us drive the business at the end of the day. So I just want to dwell on this a little bit. This is a real issue that every time we implement on a DDOM kind of concept, we're going to have to cross that bridge. It's very important to recognize it. There are metrics that do make sense. There's a great book out there around smart metrics that Chad Smith and Deborah Smith authored, which is a great read and gives you some different ideas about that as well. But you want to keep this in mind as you go into the implementation of your DDOM. So if you think about it, this is a very colorful chart. I love it. But we've applied decoupling points, we've applied control points, we've applied appropriate buffering, and we're pacing to actual demand in the market. And this is kind of the way we want to think about it. We've got capacity buffers here at these upstream resources. This one's in a little bit of danger, so we may want to pay attention to that over time because it could move into the realm of becoming a constraint that we would want to either address and change our model or gain additional production resources. We've got stock buffers placed strategically now to dampen supplier variation. We've got a stock buffer here to ensure that we can pace to actual demand for those customers on the make to stock items. And for those customers ordering make to order items, we put time buffers in place to improve our promise date performance. And this is really a great visualization. I love this chart the way they've done it because it kind of puts all of those dimensions on the same page. This is how you get leverage. I talked about Goldrat's, quoting of Archimedes all the time. Give me the lever long enough, a place to stand in a fulcrum, and I can move the world. And find the point of leverage. It's not optimizing every one of these. It's just ensuring you've got enough bandwidth in these non-constrained resources. It's getting appropriate control of those production resources that really need the right attention and are, at the end of the day, going to dictate the output of the entire system. And wait as long as possible. Pace to the real demands. Prioritize those make to order demands and these stock buffer demands based on their buffer status. Use that as a schema for influencing how you set your production schedules. What you're trying to do is build agility into this model, whatever your model looks like in your own environment, to give you that flexibility to configure and adapt to the real demands that are coming in from the marketplace. We've talked about this quite a bit. I'm not going to dwell on it too much, but I think these points are all pretty well understood from the comments we've had here. We want the supply order generation for materials driven by the DDMRP equation wherever we can. It's not for every item. There are some items that don't make sense to buffer because you're going to just be spending way too much money on working capital to cover the high levels of variation those incur. But there's great tools to help you understand where and where not to apply DDMRP buffers. Time buffers and capacity buffers help us manage variation in the production flow, and they give us better ability to improve our on-time and full order promise rates. The idea of control points help us control the release of materials onto the shop floor. That minimizes the amount of work in process that we're dealing with and helps us understand how to pace material into the plant so that we get the right throughput. What we're after is promise date performance, improving that substantially through the appropriate deployment of the demand-driven operating model. And I hope that these illustrations have really given you a good understanding of where we can operate, how you can deploy a model like this into your environment. Not going to go too much deeper on this because we're kind of running short on time, and I think there's still some additional questions. So let me take a break here and we'll see what other questions have come up. Are we going to share the presentation and the recording video? Absolutely. The presentation and webinar recording will be available for you. We'll be distributing that out afterwards. If I have a forecast with 20% accuracy, which is the best way I can guarantee materials with safety stock? Great question. 20% accuracy, that's not very good. So I'm sorry if you're having to deal with that in reality. Yes, stock buffer can help on that, but there's more to that question that I think we would want to know. Like how frequently, what is how many demand pulses do you have in a year? Because what you don't want to do is just be configuring safety stock against that 20% accurate forecast. I would be heavily advocating for looking at your historical rates of demand, how much variation those incur, and building a stock buffer that would allow you to pace to actual demand coming in. Leaning into the buffer, meaning putting more buffer stock in place so that we can ensure we have constant availability and gain control. If we find that we're more than saturated with inventory while we do that, after we've run for perhaps a month or two, then we can start to lean out the buffer settings and give us a better position. So that's an important factor when you look at your DDMRP buffering. Don't think of it as safety stock. Think of it as a stock position, a stock buffer. Safety stock and DDMRP buffers do not behave the same way. And you don't want to fall in the trap of thinking of them as synonymous, because they're not at all. And we'd be happy to meet with you to kind of give you a deeper explanation on that afterwards. So don't hesitate to reach out. Next question, do we consider pooled capacities as well? Pooled capacities, I think, would mean things like we've got multiple resources of a given resource type. For example, we've got 10 lays all equivalent. Yes, absolutely, pooled capacities are considered in the scheduling solution and how we manage those. Final question here, I think. Do we get a participation certificate for the sessions? No, there's no certification for these. These are not like the Demand Driven Institute classes, where you can take a test and get become a certified demand driven planner, or DDPP as it's called. These are more educational in that regard, but I encourage you to use the Demand Driven Institute's website. We also offer education, so we can provide education services for you and members of your team at your location if that's of interest. Next question, what is the difference between having a buffer and safety stock approach? Buffer comes at a cost, doesn't it? Well, safety stock does too. In MRP concept, safety stock is an artificial floor. It says, I never want my inventory to go below this point. It's a planned down to number. So instead of it being 0, we're going to say we want 10 days of coverage in safety stock, because that's our tactic for never stocking out. So you're inherently making a buffer, a working capital commitment when you do that. In reality, what we find is that the buffering logic compared to MRP will typically reduce inventory holdings by 25 to 35%, and in some cases much more than that. So you do not want to be in this paradigm where it's analogous. So I would really encourage you, Ahmed, to really take a full DDMRP webinar, or to go through the DDPP training program, because it'll really give you a more deep understanding. One of the things we do for our clients is we do simulations of their demand activities, their historical demand. So we can actually show you how a DDMRP buffer would have behaved given the demand patterns that you've experienced for your items. And it's a great way to learn more about how the buffering concept works, and as well to get a better understanding of how applying it in your environment where and how you would apply it. And so those are the kind of the techniques that I would suggest that you follow, and we'd be happy to help you with some simulations there, Ahmed. Could you say the conference or training about? I don't understand your last question. Could you say the conference or training about buffering? We don't have a DDMRP module in our agenda. We're going to have some case studies that, from our clients that will be talking about their experience in applying DDMRP. But again, there's DDMRP training available. You can go to the Demand Driven Institute's website and find their training material available there. And you can register for courses, or you can reach out to us directly, and we'd be happy to try and get some education aligned for you directly. Okay. I think we're at the end here. Let's see if there are any final questions. Nope, I see Nicole has distributed the information about the materials and the recordings that will be available here and the schedule for the event. Yep. Okay, well, look, everyone, thanks so much for your time today. I really appreciate your participation. The demand-driven operating model takes us to the next stage. You know, we started with DDMRP and so many clients, but you can't also not ignore, or you can't ignore the fact that your operating model is a key part of the equation here that you want to deal with. And that's where you'll introduce time and capacity buffers, where you're going to kind of bring the two worlds together. DDMRP as a method is working incredibly well, but it's not really that tuned into what your real capacity situations are. So the linkage together, these two together in that demand-driven operating model, gives us the ability to create more agility in our business, improves our on-time order fill rates, and while all at the same time pacing to actual demand out in the market. So with that, we're going to adjourn. Thanks everyone so much. I hope you're able to join us again tomorrow morning. We did a great case study discussion. I'm going to be interviewing John Spitali from Greif, which is a global packaging company that we've been working with over the past few years. And we've got a number of other great sessions on the agenda for tomorrow. So really looking forward to spending the next 3 days together. And hope you have a great day, and we'll talk to you tomorrow. So thanks, everyone.